Okay, today guys we are going to be talking about congruent triangles, and to have congruent triangles that means that you have two triangles that have exactly the same measurements. It can be the sides and the angles. Everything's going to match up perfectly, in other words. The way that we're going to mark that, sides that match up are going to be marked with little slashes, as I'm doing here. And that tells me which sides match up by the number of slashes that they have. And if, for instance, two sides had the same amount of slash marks, so if DJ only had one slash mark, that would also mean that it would be the same length as TD. But I've marked all three of these different because we don't know the measurements here on these triangles. We haven't measured them, so we can just make that assumption to begin with that they might be all three different lengths. But again, those marks match up with their partners in the other triangle. Angles also work the same way. You do these curved marks in the corners, and I'm matching the number of curved marks for the angles that match up. And again, that means the same thing. Here I know that T is the same measurement as F. I know that D is the same measurement as R. If you had two of the same measurement in a triangle, then you would know that those two angles had the same degree. They would have the same markings. Sometimes you're asked to write a statement about what a congruent statement, the triangles that are congruent. For the first one, you can just write the letters down in any order you want. I'm going to write TJD. But when you say that that is congruent to this other triangle, this yellow one over here, I need to match up the parts in the same order that I have them here. So I need to find what T matches with. Well, T matches with F, so we're going to start with that. J matches with C, so that'll be second. And D matches with R, so that'll be third. So this will be my congruence statement for these triangles. The next important question that may need to be answered is, are the triangles congruent? And there's 5 different ways that can happen, that you can prove that they're congruent without having to match up every single angle and every single side. The first one is side, side, side. And what that means is I have a picture with two triangles in there, and I can tell that all three sides have a matching counterpart in the other triangle. So all three sides are marked in each triangle, and they have the same marks. Everything's lining up. That would be side, side, side. And that would tell me that these two triangles are congruent. So even though I didn't mark any angles, if I know all the sides, I then know all the angles. I have just proven that everything matches. If you are in another situation called side, angle, side, you will have two triangles, and I'm going to turn this one around the other way. And forgive my drawing, please. But in this situation, you'll have matching sides, two sets of those. The angle falls between the S's over here. It's got to fall between the sides over here. So the matching angle that you know has to fall between those. So when you read the picture, it's like side and then an angle and then a side on both triangles. You hit that same order. If you know these 3 things about both triangles, then you can make the assumption that everything else in those triangles matches up. A third way to tell if they're congruent is angle, side, angle. So I'm going to draw us some more triangles here. And in this case, you'll notice the side is between the angles. So in a triangle, you might have 2 angles marked, and in another triangle that's near that, you will have 2 angles marked, and they'll have the same marks. They'll match up. The side that's marked has to be between those in both pictures. So it has to be in the exact same placement. Again, if you know you have angle, side, angle, then you can make the assumption that the other angles or sides that you have not marked also will match up. The next one is angle side. And it follows the same kind of idea as these others. If you have two angles labeled as matching, and then a side that comes after one of the angles, so outside of that, that's angle side. And so basically, if you're ever given two angles and a side, it's going to work. They're going to be congruent triangles. The last one is hypotenuse leg. Well, to have a hypotenuse, you have to know that you are working with a right triangle. So you're almost just being given an angle right there. A leg is one of the sides that's not the hypotenuse. So first of all, let's start with hypotenuse. The hypotenuse is across from the 90-degree angle. If you know those are matching, the leg can be either one of the other sides as long as it has the partner to match up with it. And that would fulfill the requirements for hypotenuse leg. Again, that's because it's a right angle. You know that these two sides follow the rules that we need for congruent triangles. Now, notice this would be angle side, and I'm not going to write that down because that's a little sketchy to write down. It doesn't work for any other situation other than having a right angle. So I'll write it down backwards. No side angles. That is not a rule. You cannot assume that triangles are congruent if you have side and angle, and it's not hypotenuse leg. If you know it's a right triangle, you know it's hypotenuse leg, it's fine. It's a congruent set of triangles. But if it's any other situation without a right angle, you cannot assume it. A really common geometry problem is to be shown a picture and asked if the two triangles are congruent. And they're wanting you to use the theorems that we just talked about with the sides and the angles and make that determination. Something that isn't always obvious is that a shared side is congruent in both triangles. It's part of both triangles and the length of it is the same, so it's not changing. So if I were looking at this picture, I would say yes, these two triangles are congruent. I have two sets of sides that are marked as being congruent, but because they share the side BD, I can put marks on it and count it for both triangles. And so this follows side, and these two triangles would be considered congruent. Another thing that you can use to your advantage is that vertical angles are congruent, and they can be used in both triangles. And so here's a situation that we have vertical angles across from each other. So you can mark those yourself as being congruent and consider those in both triangles. These had two sets of marks already on the sides, and if you didn't consider the vertical angles, then you would probably be stuck. But since we have the vertical angles and I've marked them, I can easily tell now that I have side, angle, side as the reason these two triangles are congruent. A third piece of information that can be helpful is alternate interior angles. Those are congruent and they can be used in both triangles. This is a situation where that comes up. The first thing you want to do is realize what is parallel. FG has that little arrow mark and EK has the little arrow mark. That means that those two lines are parallel. The alternate interior angles have to touch those lines. So this one and this one are the alternate interior angles that I am referring to. And I can mark those. This is also a case where they have a shared side, so I can mark it. Once you have marked those things, you can tell that it is side, angle, side. And that is why they are congruent. Okay, I'm going to talk about a couple of other situations that can happen. This is one where they use the word bisect, and that means to cut in half. And so whenever they give you that kind of information, I want to go ahead and mark my picture with what it's trying to explain to me so that I can see what I have. If you look right now, nothing is marked on here, so you might think that these are not congruent, but they actually end up being congruent. So AE and BD bisect each other. It means they cut each other in half. So if I look at AE, it's going to be cut in half, and BD is going to be cut in half. So I'm going to mark those as being equal amounts on each side of the middle. The other thing that shows up in this one is vertical angles that we mentioned a few minutes ago. And so the shared vertical angle, or vertical angles that are made between these, can be used in both triangles. And now I can read that I have a side angle side situation, and therefore these two triangles are congruent. Okay, here is another situation where we have a blank set of triangles and some information given to us. And again, in that situation, we want to mark what we know. The first thing says GK, segment GK, bisects angle JGM, so that's this top angle here. And that means that this side and this side would be equal. So I can mark that. The other thing it tells me is that GJ and GM are congruent. So again, I can put marks. This is another situation where these two triangles share a side, so I can mark that even though that's not written in the directions. And now I have three things marked. I can tell that it is side, angle, side. And both of these triangles are congruent because the matching parts match up the way they're supposed to with the correct theorem. Okay, now I have several examples that we're just going to talk through and discuss whether or not they're congruent and which theorem would apply if they are. The first thing that I notice about this one is that we have right angles, and so hypotenuse leg immediately comes into my mind. I know that the right angles are congruent, I know that the two sides marked are congruent, and I also know that I have vertical angles which are congruent. So is there a way to know that the hypotenuses are congruent? Not right now. Just based on these things, I'm not going to be using the hypotenuse leg theorem. I'm actually going to be using angle, angle, side because they're in that order. Angle, angle, side. So just because there's a right angle doesn't always necessarily mean that it is hypotenuse leg. To the next one down here with all the parallel sides, you have these two sides parallel and these two sides parallel. You have alternate interior angles in both situations. You have an alternate interior angle here and here that match. You also have some here and here that match. So you have two sets of angles, and if we can get one side, we know we have some sort of rule. And since they share a side, I can mark it. So if I read this now, I have an angle, then a side, then an angle. So it's angle, side, angle. When I move to this top one, I have two angles marked. They do have a side marked, so I'm going to mark it. When I read this one, it's very similar to this one down here. I have angle, side, angle marked in the lower triangle. But in the upper triangle, the side is not between the angles. I have angle, angle, side. So in this case, even though you're getting some of these, they have to match the same in both triangles. So this is not enough information. If they don't match perfectly, then you don't know for sure. Our last one down here is one where again we have right angles. And this time we do have our hypotenuses marked to be congruent. And so I'm just looking for a leg. Well, they happen to share a leg. So I'm going to mark it. And this is a hypotenuse leg telling us that these two triangles are congruent.